Hello guys, this is Neha. Welcome to my channel Guruaura. And in today's video, we are going to talk in detail about how a function is written and we'll solve some problems related to the topic function. So let's start with the function notation. We have already seen that a function is a special relation. In mathematics, a relation f from a set A to a set B is said to be function if every element of set A has one and only one image in set B. Now let's look at the two sets A and B. Set A with the elements 1, 2, 3 and 4 and set B with the elements 2, 4, 6 and 8. Let's study the arrow diagram. For the relation y is equal to twice x, we know that 1 times 2 is 2. So, we relate the element 1 of set A to the element 2 of set B. Next, 2 times 2 is 4. So, we relate the element 2 of set A to the element 4 of set B. So, next we relate the element 3 of set A to element 6 of set B because 3 times 2 is 6. Similarly, we get element 4 of set A to element 8 of set B. We see that each of the elements of set A has only one image in set B. So, the given relation is a function. We can visualize a function as a rule which takes an input, performs an operation on it and gives an output. Suppose we are giving 1 as an input. This gives us 2 as an output. If we are giving 2 as an input, this gives us 4 as an output. If we are providing 3 as an input, we are getting 6 as an output. And for 4 as an input, we are getting 8 as an output. So, what is the operation done on the input? We are just multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. And 4 times 2 is 8. Thus, a function is something that takes each value from the input set and relates it or maps it to a value in the output set. We can also say that a function is a rule that drives the output based on the operation performed. Now, let's talk briefly about some common function notation. So far, we have been writing function like this, y is equal to 2x. But we will often see the same exact function written like this, fx is equal to twice x instead. But why? Why did the variable y get replaced by f parenthesis x? Well, this is the most common way to represent a function. This notation simply means that a function f takes an input value x and gives an output value y. So read as a function of x equals y or f of x equals y. To understand it better, instead of using the abbreviations for f, x and y, let's see the standard names. Function for f, input for x and output for y. This way the notation becomes more clear. Yes? Now, using fx gives us the notation for evaluating the function. Now, if we provide the input values of x, we can easily get the output values by evaluating the given function. Let's take an example. Function fx is equal to twice x. Now, if we substitute the value of x with 4, we get the output as 8, which is twice of x. Similarly, the value y will give the output as 10 and 6 will give the output as 12. Now, this is read as f of 6 is equal to 12. f of x is equal to y is the most common notation, but you can use other if we want to, like g of x is equal to y, g of a is equal to b, f of a is equal to b, or h of a is equal to b. Now, let's take an example. Let a and b be two sets with the elements -3, -2, -1, 0, 1, 2, 3 in the set A, and set B with the elements 0, 1, 2, 3 up until 9. And f is defined from A to B given by fx is equal to x square. Now we have already come through this. What is this? What do you understand by this? Function f from A to B. Function f mapping elements of A to elements of B. Here A is the domain and B is the codomain. And how do we read this? We read it as f of x is equal to x square. This notation simply means that the function f takes an input value x and gives us an output. We can map this in a table like this. Here in the first column we have the input values, in the third column we have the output values, and the operation is performed in this center column. If we take the input as 3 and perform the operation x square, that is 3 square, we get the output as 9. Next, if we take the input as 2 and perform the operation 2 square, we get the output as 4. Similarly, if we take the input as -2 and perform the operation as -2 square, we get 4. In this way, we perform the operation on the input and get the output values. This is the arrow representation for this function. Here, set A is the domain and set B is the codomain, and the range consists of the elements 0, 1, 4 and 9. Hope you are clear till here. Now, let's see our first question. A function f is defined by fx is equal to twice x minus 5. Write down the values of f of 0, f of 7 and f of -3. So let's try solving this. So the first one, f of 0, that means the input value is given to be 0. Now, f of 0 is equal to 2 times 0 minus 5, which will give us the output value as -5. Next, if we take the input as 7, it will be 2 times 7 minus 5, which will give us 14 minus 5, which is equal to 9. Next, if we take the input as -3 and substitute the value of -3 for x, we get 2 times -3 minus 5. 2 times -3 will give us -6, minus 5 will give us -6 minus 5 will give us -11. Now let's see our next question. The function t, which maps temperature in degrees Celsius into temperature in degree Fahrenheit, is defined by T of C is equal to 9C by 5 plus 32. Here you need to find T of 0, T of 28, T of -10. The value of C when Tc is equal to 212. So let's try solving this. So in the first question, we have T of 0. Here the value of x is 0. In this case, the variable is C. So T of 0 is equal to 9 times 0 divided by 5 plus 32, which will give us 0 plus 32 is equal to 32. Next, T of 28. Now, on substituting the value as 28, we have 9 times 28 by 5 plus 32. 9 times 28 will give us 252 divided by 5 plus 32. Now, on taking the LCM as 5, we get 252 plus 160 in the numerator divided by 5, which will give us 412 divided by 5. Next, let's see the third one. Here, f of minus 10. Here the value of c is given to be minus 10. So if we substitute minus 10 for the c, we have 9 times minus 10 divided by 5 plus 32. What is 9 times minus 10? It will give us minus 90 divided by 5 plus 32. On taking the LCM, we have in the numerator minus 90 plus 160 divided by 5, which will give us 70 by 5, and then on simplification we get our final answer as 14. Now the third question is a bit different. Here the value of c when t of c is equal to 212. This time we know the value of t of c, which is 212, and we need to find the value of c now. Fine. So we substitute in place of t of c 212 is equal to 9 cross c by 5 plus 32, and now we have to find out what is the value of this c. So 9c by 5 is equal to 212 minus 32. How the minus came here? We took the 32 from the right hand side to the left hand side. Fine. So we have 212 minus 32, which will give us 180. Now c is equal to 180 times 5 divided by 9. On solving this, we get the value of c to be 100. Hope you're clear till this. Now let's see the next question. Let's try to solve this. F of 1.1 minus f of 1 divided by 1.1 minus 1. So given f of x is equal to x square, and we need to find the value for f of 1.1 minus f of 1 divided by 1.1 minus 1. Now what we will do is f of 1.1 will be equal to 1.1 whole square. Why? Because f of x is equal to x square, and f of 1 will be equal to 1 square. Now in the denominator, 1.1 minus 1 will give us 0.1. Now in the numerator, if we have a look, we have a square minus b square. Yes, we have a square minus b square, and we know that a square minus b square is a minus b into a plus b. So what will happen? If we do a minus b, that means 1.1 minus 1, and a plus b, that will be 1.1 plus 1. Yes, so 1.1 minus 1 will give me 0.1, and 1.1 plus 1 will give 2.1. Now on multiplying the numerator, we'll have 0.1 times 2.1. Yes, and in the denominator we have 0.1, but what we can do is we can just cancel out this. Yeah, so we have our final solution as 2.1. Clear? Hope you're clear with the function notation and the problems we have solved. In the next video, we will learn about real functions and how to perform operations on real functions. Don't forget to like, share and subscribe my channel. Thank you.